Assume that there is no compression of roving during winding and each coil of a layer is placed directly over the coil of the previous layer. A full roving bobbin consisting of 50 layers of roving is wound on an empty bobbin of 60 mm diameter. If the diameter of the roving is 1 mm, then the diameter in mm of the full bobbin in an integer is. It is also a 1 mark question. So what they are saying is it is a bobbin of 60 mm diameter, and in this each coil of layer is wound directly over the another, matlab first layer, then second layer, then third layer, and then n number of layers are wound to the each layer. A full bobbin contains 50 layers are first layer, second layer till 50th layer of roving on an empty bobbin of 50. It is an empty bobbin that is of 60 mm diameter. If the diameter of the roving is 1 mm, the roving that is wound is of 1 mm, then the diameter of the full bobbin after the roving is wound on the bobbin, then what becomes the diameter? It is asked. So it is a after one layer of roving, what will be the diameter after one layer? Since it is wound on both the sides, so what will be the roving? So the diameter is 2r, so diameter becomes 60 mm plus 2 into 1, diameter both the sides of the bobbin, matlab forward first front side and second the back side, so 62 mm diameter of the first layer. And similarly for the second layer, 60 plus 2 into 2, so on and so forth. For after 50 layers, what it comes out to be, diameter will become 60 plus 2 into n means number of layers, 60 plus 2 into 50, so 60 plus 100, it comes out to be 160 mm. This is your answer. So the answer is 160. It is a 1 mark question. So you just need to know the basics ki how this wound is done and why it is 2 into n, since it is a front and a back thing. So 2 into 1, matlab whatever is the diameter of the roving, it is on the front side and as well as on the back side, and you need 50 layers, so 60 plus 2 into n, that comes out to be 160 mm. Now coming to the next question. If the reflectance of the dyed fabric at lambda max, maximum wavelength, is 10%, then the color strength value K by S of the dyed fabric correct up to 2 decimal places is. You just need to know what is K by S value. Higher the K by S value, higher the color strength. So K by S is a color value, color strength parameter. So what is the value based upon the reflectance of the fabric? So if you have read, K by S is equal to 1 minus R whole square upon 2R. It is a formula of K by S value, and a reflectance is measured in an absolute terms. So if it is given as 10%, so 10 upon 100, it comes out to be 0.1. So just write the value 1 minus 0.1 ka whole square upon 2 into 0.1, 0.9 ka whole square upon 0.1. When you solve this, it comes out to be 4.05. So the answer should be given in 2 decimal places. So this is the 2 decimal places, 4.05 is the correct answer. So these are all 1 mark questions that I have discussed so far. So in this question it is written that match the properties listed in group 1 with the corresponding measure techniques given in group 2. The correct option is, so there are 4 options listed in group 1 and 4 options listed in group 2. You have to match them correctly based upon their functions and their role. So it is a 2-mark matching question. So this is a very simple question. If you know the basic functions, what SEM measures, what wide angle X-ray diffraction measures, what is the role of birefringence. So talking about P, crystallinity. So if you know, crystallinity is measured by wide angle X-ray diffraction. It helps to find the amount of crystallinity percent in a total region, the amount of crystalline percent, and as well as the amount of amorphous percentage. So the correct option for P is third. And for thermal stability, TGA is used, thermal gravimetric analysis. So for Q it is 1. And SEM, surface morphology, is measured by SEM, is scanning electron microscopy. It is used when you want to see in a microscopic level, micro nano level. So the surface, what kind of surface is there. If you have seen the surface morphology of different fibers such as cotton, jute, so it is measured by SEM. And birefringence, orientation is measured by birefringence. So we get that for P it is 3, and for Q it is 1, and for R the correct option is 4, and for S the correct option is 2. 3142. So 3142, the correct option is option number B. So it is a 2-mark question. Coming to the next question, it is also a 2-mark question. It is an assertion reason type question. There are two statements given. One is assertion and second one is reason. In these types of question, you have to find that the statement that is given is true or false. If it is false, then you can answer the question directly. If the statement, that is assertion, is true, then you have to find the reason for the correct statement. And there are there are options that is listed in A, B, C and D. You have to match them correctly. So coming to the question, assertion is given as, in viscous rayon manufacturing process the fibers develop a skin core structure. And the second one, the reason that is given is, during extrusion the polymer molecules near the wall of the spinneret tend to orient less as compared to the molecules at the center of the fiber. So for this you need to know ki what is the reason, what is the assertion. So you need basic understanding of viscous manufacturing process. What is viscous? What is viscous basically? It is a regenerated cellulose. And talking about the manufacturing process of viscous, so the manufacturing includes many steps. The first one is steeping, then shredding, then aging, then xanthation, then ripening, then the spinning solution is prepared, and finally it is filtered, and the from the spinning solution, and the viscous fiber is produced. So if you know that the fibers in this process develops a skin core structure, this is right. So assertion is true. But during extrusion means the during the spinning process, when the fiber, when the molten spinning solution gets extruded from the spinning solution to the outside, so the polymer molecules near the wall of the spring tend to orient less as compared to the molecules at the center. So this is wrong, because in this the polymer molecules near the wall of the tend to orient not less, they are more. So the reason that is given is wrong. So if the assertion is true and the reason is false, then you can match the option A is true but R is false. So the correct option is option number D. Now coming to the next question, it is also an assertion and reason type of question. In this it is written that the assertion is, para-aramid fibers have better mechanical properties as compared to meta-aramid fibers. So you need to know what is para-aramid fibers and what are meta-aramid fibers. And the reason that is given, the chemical structure of the para-aramid fibers allows them to pack closely. So what is pararamid? Pararamid is a type of a polyamide that have high strength. Matlab these are high strength fibers. Total aramid fibers are high strength, metaramid as well as pararamid. And talking about the pararamid fiber, it is a highly crystalline fiber and it is very strong. Due matlab the reason why it is very strong, it is due to the high crystallinity of the pararamid fibers. The molecules between them are very closely packed because the total structure is crystalline. There is no more amorphous space that between the molecules, so they are very closely packed, and due to the very close structure, the intermolecular bonding is very strong between the molecules, so these are very strong. What is the example of pararamid? Kevlar. And for metaramid, what is the example? Metaramid, the example is Nomex. So these are very important structures. You need to remember them very carefully. So talking about the metaramid fibers, it is a polyamide. The properties of metaramid fibers are they have very high heat resistance, and they are not totally crystalline. They are semi crystalline fibers. So the properties, since they are very high crystalline and this is semi crystalline, the properties, mechanical properties, they are better in para-aramid fibers. This is true. And talking about the reason, the chemical structure of para-aramid fibers allows them to pack closely. I have told you just recently, due to the very high crystallinity, the intermolecular bonding between them is very uh, strong, and there is no space between them that makes them strong, and the chemical structure itself is very closely packed. So the para-aramid, the reason is true. I think you have understood the reason and as well as the assertion. So they are both the statements are true. And also, what is the reason for better mechanical properties? This is due to the high crystallinity and the chemical structure of the para-aramid fibers. So the reason is reason is correct for the given assertion. So option A would be correct. That is, both assertion and reason are true, and R is the correct reason for A. Option A is correct. Now coming to the next question. It is also a 2-mark question. In this question, it is given that keeping the speed of all other components of a carding machine unchanged, the angular velocity of a cylinder with damaged wire points in an area of 2 cm cross 2 cm is doubled. Then the wavelength of the periodic fault in the card sliver would be, 4 options are given: same, half, double, triple. So this is a typical 2-mark question, and that is a numerical type of question from the yarn manufacturing process, that is carding machine. So in this type of questions, you need to find what is given and what is asked. Just write all these things. So in this question, it is given that the speed is constant. The speed of a carding machine remains unchanged. That means it is constant. So speed remains constant. And then angular velocity for second. So angular velocity V2 is twice, is doubled. Angular velocity of a cylinder which damaged wire points in an area 2 cross 2 cm is doubled. So V2 is equal to 2 times V1. Also, we know that wavelength of a periodic fault is inversely proportional to the angular velocity, and you need to find the wavelength. So wavelength is inversely proportional to angular velocity. Angular velocity. So you need to find the angular velocity wavelength. So angular velocity is given, and simply you can solve this question. So for wavelength 2, for first wavelength it is denoted by lambda 1, and for second wavelength it is denoted by lambda 2. So lambda 2 upon lambda 2 is upon lambda 1 is inversely proportional to 1 upon V2 upon V1. for two, for first wavelength, second wavelength. I have written this directly, solving this. So lambda 2 upon lambda 1 is equal to V1 upon V2, and lambda 2 upon lambda 1 is equal to V1 as V1, and V2 is given as, yeah, this is given 2 times V1. So we can get lambda 2 is equal to lambda 1 upon 2, and this is the answer. The wavelength of the periodic fault in the card sliver would be halved. What is the existing is lambda 1, and what is the new wavelength is lambda 2. So option B is the right answer. The wavelength of the periodic fault will be half. So coming to the next question. This is also a assertion reason kind of question. In this question, the assertion is given as compared to a parallel wound packages, ring bobbins exhibit lower tendency of slug off during unwinding. And the reason that is given as the main winding layers in the ring bobbins are separated by cross winding layers. So it is a 2-mark question. So you need to understand what is slug off, what is the function of parallel wound packages, or what is the function of ring bobbins, what is winding layer, what is cross winding. You need to know these terms clearly. So what is slug off? Slug off is a defect that occurs during an unwinding of a package. A bunch of coil slips, and this is kind of defects occurs during the unwinding process, where a coil slips, the layers get not arranged properly in a proper manner, and it result in a defect called slug off. And what is the outcome of the slug off? It results in an excessive yarn wastage and uneven die pickup in case of our die packages. So this is the typical meaning of a slug off defect. So what the reason is given in parallel wound packages, matlab yarn packages are arranged parallelly, and the ring bobbins exhibit lower tendency of slug off because during a parallel wound package, the slug off tendency, that is the tendency for coil slipping, is very low during the parallel wound packages in a case of ring bobbins. So the assertion is right. And what is the reason? The main winding layers in the ring bobbins are separated by a cross winding layer, because when the yarns are arranged in a cross winding layer, as you have seen in a typical during the flying of a kite, we wound yarns in a bobbin, generally typically in a cross winding layer. So during cross winding layers, the tendency of the defect becomes low. So the reason is quite simple, and this is the correct reason. So both the assertion and the reason are true, and reason is the correct, and R is the correct reason for assertion. So option A would be the right answer.